Here's a FRQ, a four-pointer, and it has an interesting twist to it that I think we should look over to give you some advice on. First of all, the first question on this four-pointer is write a balanced chemical reaction for dissolution. That's the word that they use in AP Chem for dissolving, and it's calcium hydroxide line in pure water. Okay, that's a pretty common compound on AP exams, and we've got that calcium hydroxide, which is a solid. It's an ionic substance, and then it's going to turn into calcium plus 2. It's ion, and those two hydroxides are going to be a coefficient of 2. You need the charges. These charges are wrong, you lose the whole thing. And of course, naturally, we've got a balance. But this is pretty straightforward. I think there's no evil twists in it that you'd have to worry about. Now, here, B, calculate the molar solubility of calcium hydroxide. That'd be a tough enough question all by itself, but in 1/10 molar calcium nitrate. Now, nitrates are spectator ions, so you don't have to worry about that in the solubility. And here we've got to deal with 1/10 molar calcium. Well, let's see how that plays into this question that makes this one tough. We've got to have the KSP equation. I'm surprised they didn't give a point for that, but they didn't. So KSP is equal to calcium ion, and this becomes a superscript. Now with molar solubility, we would use this S and 2S. And of course that's squared. So it's the amount of calcium hydroxide that will dissolve. So that's coefficient of 1. So we've got that. They give you the KSP as being 1.3 times 10 to the negative 6. Moderately small. That's our equation. And normally you'd solve that. That'd be a 4s cubed. You could put that pretty easily into your calculator to solve. But here's the twist. It's in 1/10 molar calcium. So this isn't just plain calcium. They've got some calcium in there ahead of time. So you're going to have to toss in that 1/10 molar into this, complicating this. KSP. And we've got the 1/10, and then how much will dissolve on top of that, then the 2S. Now this is going to be a tough equation to solve. I don't want to FOIL this out. No. Here's the rule. If the equation is too complicated, that you need a quadratic, or if you use solver to solve it, that's not the one you're going to use to solve. What you will do easily is realize that typically when you solve some of these, the solubility is really, really small. So if you add a small number to 1/10, it's still going to be 1/10. It's the simplifying assumption. You've done that with acid ionization. So you can rewrite this. Too difficult to solve without a quadratic. Simplify based on the low solubility. I have X here because originally this was set as X, but I should say S, the molar solubility will be small. So now, instead of having that equation, we've got this equation. We've got just 1/10. And this is pretty solvable. Take 1.3. Oh, in fact, let me solve it. I'm going to get my TI out. Here it is. Let's see. We're going to take our 1.3 second function E and divide it by 1/10. 2s squared make it a 4, so divide it by 4. Now, take the square root of it. So second function square root, our last answer. Enter. 0.0018, and indeed minus x was pretty small, so that would be the point for this, and you would end up saying that's the molar solubility. And you get 1 point for the correct stoichiometry and setup, and then 1 point for the final answer. A lot of work for 1 point on this. If you don't believe this and say, I want to solve it anyway, you're making a mistake, because this is supposed to be solved in 10 minutes, and you still have C to deal with. So save yourself some time and make the simplifying assumption. Make the simplifying assumption. This is what you would do if you did it the long way. If you're doing it this long way, you know you're doing something wrong. If it's taking too long, you're doing it wrong. That's the rule. But let me show you how to do this for those of you who want to use solver. I'm going to go to our math functions, and it's the bottom one. So I'm going to go reverse and put enter to get the numeric solver. We're on our left is going to be our 1.3, and again times 10 to the negative 6. That's the left of our equation, and I'm going to enter that. Now we got to write our equation, which is a little tricky. This is going to take 0.1 plus and I'm going to use their x, parentheses, close parentheses, 2x, and then I'll square that. I double check because it's easy to make a mistake on this. 1.3 times 10 to the negative 6, 0.1 plus x, 2x squared. Now I'll click this again, start at 0 and hope it moves up, and then solve it. And there's our answer, 0.0018. I think that takes longer, and a lot of people don't know how to use solver right. In fact, when I did this the first time, it got wrong. Again, you can take my advice or don't take your advice. You're allowed to use the calculator. Maybe you want to have it do this tough work because you paid so much money for it. But that's our solution. 0.0018 gives you the point. And the moral of the story is, I'm not sure you'll believe me, if you're taking too long, you're doing it wrong. Simplifying assumptions, work on AP chemistry. Here's our answer, 0.0018, without the simplifying assumption, and there it is. That's the same answer, 0.0018, the 2 sig figs. So choose your poison. On to the next. FRQ. Good luck on this test.